Hi, here a table has been given which represents a summary of a sample of size 55 from a Poisson distribution. Okay, well, let us denote x follows Poisson distribution with parameter lambda. Now here each xi is given and for that frequency fi is given. So first question is we have to find MLE of probability x equals to 2, and then using r function dpoise we'll find the realization of this MLE of probability x equals to 2. Okay, now we'll start finding the observed sample mean. See, xifi is given, so observed sample mean x bar equals to summation I runs from 1 to 6 xifi whole divided by summation fi 1 to 6. So here we'll find the xifi. This will be 0, 14, 24, 39, 24, and 15. So summation fi equals to 55 and summation xifi equals to 116. So observed sample mean will be 116 whole divided by 55, which is 2.109. Okay. Now let us take m random variables x1, x2, so on xm. Each follows Poisson distribution with parameter lambda. Okay. Now the theoretical sample mean is expectation of x bar. This is the theoretical sample mean. Now this is 1 by m summation j runs from 1 to m expectation of xj. So answer will be lambda because expectation of xj equals to lambda. Okay. Now we equate this theoretical expectation mean to the observed sample mean to get the MLE of lambda. Okay, now expectation of x bar equals to lambda equals to x bar. So clearly MLE of lambda hat equals to capital X bar. Okay, now we find probability x equals to 2. Probability x equals to 2 equals to. Okay, first of all, x follows Poisson distribution with parameter lambda. So probability mass function px equals to probability capital X equals to small x equals to e to the power minus lambda to the power x whole divided by x factorial, where x runs from 0, 1, 2, so on, and lambda greater than 0. So probability x equals to 2 will be e to the power minus lambda square whole divided by 2 factorial. That means e to the power minus lambda square whole divided by 2. Okay. Now take this function of lambda as g lambda. Okay. Now as this function g lambda is a real one-to-one function, now by invariance property states that if MLE of lambda is x bar, then if g lambda is a one-to-one and real function, clearly it is a real one-to-one function, then MLE of g lambda is g x bar. Okay. Now, MLE of probability x greater x equals to 2. This is g lambda. Now, MLE of this probability x equals to 2 is g lambda hat equals to g lambda hat equals to g x bar, that is e to the power minus x bar square whole divided by 2. Okay. Now, by equating the observed sample mean, which is x bar equals to lambda, we find lambda hat. Now the realization of this lambda hat equals to 116 whole divided by 55. Now this is 2.109. Okay. Now realization of MLE of probability x equals to 2 we get by putting lambda hat equals to 2.109 in this equation. Okay, equals to the power minus 2.109, 2.109 whole square whole divided by 2, that is 0.26989. Okay, now in the second problem we have to use R function dpoise. Okay, now dpoise gives the probability that the probability mass function of Poisson distribution. Suppose we are finding probability x equals to x and x follows Poisson lambda. Okay, now probability x equals to x, we get dpoise. If we write in R this code, this function dpoise, and the arguments, first argument will be small x and there is lambda. So here we have to find probability x equals to 2, the realization of this MLE. So we'll write dpoise to realization of lambda hat, that is dpoise 2 comma 2.109, which is 0.26989. Okay, now I have done in R, so from that I have taken the screenshot. See here, dpoise 2 comma 2.109, we have got 0.2698958. Okay, so this is the answer. Thank you.